Welcome to Nuclecast, the official podcast of the ANWA Deterrence Center. Our host is Dr. Adam Lowther, co-founder and vice president for research at the National Institute for Deterrence Studies. The ANWA Deterrence Center is a 501c3 organization ensuring a broader understanding of the nation's strategic nuclear deterrent and its ongoing modernization. Thank you for listening and welcome to the show. The views of the host and the guests are their own.
Welcome back to another great episode of Nuclecast. Of course, I'm your host, Adam Lowther, and today we have a great guest. You may have heard her name once or twice. That is Kim Budil, who is the director of Lawrence Livermore National Laboratory, which is one of the nation's weapons design laboratories and has a long tradition and is a place that I, as a Air Force guy, spent many days, and it also has the added benefit of being located near the nation's finest wine country. And so it's a place that I have had the chance to go a day or two early or stay a day or two late from meetings so that I can go enjoy that geography. Of course, Kim, welcome to Nuclecast.
Thanks, Adam. It's great to be here.
Now, I had originally told you that the purpose of this show was to discuss your favorite wines, but I'm going to change up that format without telling you, and we're going to turn to nuclear weapons instead. Of course, most people don't know Nuclecast is also the finest. We give Wine Spectator a run for its money, but today let's talk nuclear weapons. And so, as a lab director, you are the 14th director of Livermore, and you've had some excellent predecessors.
I have. I'm actually lucky number 13.
Oh, 13. Okay. For some reason, I thought you were 14. I guess my math is off. But, I am a social scientist, so instead of an engineer. So my math is okay, but not great. That's why I did the social sciences. And so let's talk ignition. That was your big accomplishment here lately is ignition. You want to tell us a little bit about that, and then why, for our audience of nuclear aficionados and professionals, why does that matter for the enterprise and for stockpile stewardship and all of that?
Sure, glad to do that. So basically what we did for the first time ever in a laboratory, we did a fusion experiment where we produced more fusion energy out than laser energy required to drive the experiment. So we used about 2.05 megajoules, million joules of laser energy to create 3.15 million joules of fusion energy. Now, the reason this is important starts a long time ago. The original idea that culminated in this experiment began 60 years ago, shortly after the laser was invented. Early in the nuclear weapons program, after thermonuclear weapons had been developed, there was a desire to be able to study the fusion process in the laboratory. So the quest was on to understand whether you could create a small-scale, lab-based experimental platform that would allow you to delve into this physics. And at Livermore, we've been using lasers for the intervening decades to try to figure out how to make this process go. So basically, we use a giant laser to send all of this energy into a very small can, about a centimeter long, that converts the laser light into X-rays. Those X-rays bathe the outside of a little capsule that's about 2 millimeters in diameter, made out of diamond. The outside surface of the diamond blows off. That pushes the inside surface in. We fill the inside of that capsule with deuterium and tritium, heavy isotopes of hydrogen, basically. And if you can squeeze that hydrogen to high enough temperature and density fast enough and hold it together long enough, you can get the fusion reaction to become self-sustaining. So it turns out, while that's conceptually simple, from an experimental perspective, it's incredibly hard. But as we started into the stewardship era and we ceased nuclear testing, the physics of fusion was really out of our reach, because without underground testing, we had no way to really access those conditions directly. So now we have a platform in the laboratory where we can begin to explore in detail the physics of fusion and use it in new and exciting ways. So it's really cool.
So let me ask you, because one of the big issues that within the DOE enterprise and across the military as well, it's where I've spent my career, is this question of workforce. And so do experiments and, fusion. This has been a big deal. It's been something we've been looking for, like you said, 60 years. Does that help with does that get people excited and say, hey, I want to go to because the whole argument was, well, this nuke stuff, it's kind of old, we've done it, we know it, there's nothing new. So was this helpful as you go to, because Livermore always, you got lots of Berkeley grads. Can you go to Berkeley and say, hey guys, we're doing new and great stuff? Has that been useful for those purposes?
Oh, absolutely. And it has been for a long time, actually. Many people came to the lab to work on fusion and slowly learned about our national security missions and moved into other roles over time, myself included. I came to do laser experiments. And then over the arc of my early career, learned about our nuclear missions and really became a national security lifer. So, these experiments, these laser experiments, are incredibly complex challenges in material science, in physics, in computational design, in engineering. And so the best people are drawn to these really, really hard problems. And if you think about the way we take care of the stockpile today, what that really means is we need people whose judgment we can trust. So giving them these really complex problems to work on is part of how we train and test and challenge them over time to really be prepared to make the kind of high consequence decisions we need them to make. So it's an enormous recruiting tool. And since we've gotten ignition, even more so, one might say it's a beacon, drawing people to our lab at this moment. And that's great. It's really great. And I'll just note, the National Ignition Facility was built to support stockpile stewardship. Of course, one of the central goals was to achieve fusion ignition in the laboratory, but the NIF has done many other things over the last 30 years. The NIF's been operating for about 15 years. Over that period of time, we've learned a lot about material properties, radiation transport, other physics that we care about, and developed experimental platforms that would have been inconceivable 20 years ago. So it's really been quite an amazing tool for science, for recruiting, for training, for challenging, and for advancing our knowledge of nuclear weapons physics.
Now, correct me if I'm wrong, but the whole purpose of NIF and its creation originally was to serve as the Enterprise's engine, and then you kept it after the movie and turned it into something new. That's correct?
It is true that in the movie Star Trek Into Darkness, NIF played the warp core of the Starship Enterprise. So
yes,
for those of you who want to see what NIF looks like, that's a good way to get a starter. Or you can check our website.
So as we think about, you sort of, based on what you just said, it sparked a question for me, and that is, so as you bring in folks for, let's say, maybe not initially for the nuclear weapons program, maybe like you said, hey, I came here to do laser experiments. And so do you oftentimes bring folks in for something slightly different, and then they move into the nuclear program? Or, just how does that work? Do you say, hey, listen, we've got this, we build nuclear weapons and we design them, and we're in the modernization process, and I can't really tell you a lot about it, but once you get in and you get your clearance, then you'll get to see all this really cool stuff. Is that your going in proposition, or how does that often work as you bring new PhDs in?
So we do talk about our missions, all the missions that we serve, and really there's three basic draws for the lab. One is that we have some of the most amazing facilities and computational capabilities in the world. So world's biggest computer, world's biggest laser, those kind of things are really enticing tools for science. And we do a lot of great science. So we're very visible in the scientific community because we, in order to be good at science, you have to participate in that process. The second thing is as you noted, we're in California. And so that quality of life and what we can offer in terms of work-life balance, I think is really attractive to folks. And then the opportunity to be a part of something that's bigger than just your work. And that's our nuclear weapons missions, but the many other national security missions that we serve. So people are really drawn to that sense of mission and sense of purpose. And the people who stay are the ones who really feel that sense of team and commitment to serving the nation.
Now, let's suppose I were an absolute guru of workforce and I could solve like all workforce problems. I had this magical hand with workforce. And you were to say, Adam, here's the workforce problem I need you to solve. What would that problem be?
Cost of living in California, basically cost of housing. So, we're very lucky. The Bay Area where our lab is located is a very rich high-tech ecosystem. We're right near Silicon Valley, near several major, top-tier universities, a lot of high-tech industry in the area. So there's a lot of competition for people, and California is a place many people want to be. And that means that housing prices are pretty high. And so many of our employees have significant commutes that they have to deal with. And so we've worked very hard to make our approach to compensation and benefits as competitive as possible. But, we work for the government. We're not going to be going head to head with Google when we're competing for top tech talent. So it's this whole package: mission, great tools, great colleagues, work with some of the best people in the world, sense of purpose and mission, and we hope an adequate salary. But if you can do something about the cost of housing in California, priceless.
Yeah. Okay. That's an easy challenge. I'll solve that here shortly. So let's turn again to the weapons program. And so you're responsible for modernization of 2 warheads. There's this modernization process. There's manufacturing, which is, that's been one of the big issues, pit manufacturing specifically. That's not your job, but you have other roles to play. Can you tell us a little bit about that and sort of what you're doing and, what's what are the challenges? What are the successes?
Sure. So we are, as you said, responsible for the W-80-4 Life Extension Program. That's a cruise missile warhead that'll go on the LRSO, the new long-range standoff weapon, and the W-87-1 Modification Program, which is a new warhead to fly on the new ICBM, the Sentinel system. So this is a really unique opportunity. These are the first 2 truly modernized, will be the first 2 truly modernized warheads of the stewardship era, where we're really making significant changes, in part because of the necessity of changing the way we do manufacturing. So that might mean new materials or new manufacturing technologies, new tools that we're using in design and engineering, new types of partnerships with our colleagues in the production enterprise. So this opportunity to both transform the stockpile and transform the enterprise is something that we have really embraced and are pushing as hard as we can. So, we are very involved in pit production because the pits that are being built at Los Alamos are for our system. And so we work very closely with our colleagues in New Mexico to ensure that that process comes up effectively and that they're able to produce at the rate that we need to support our system. And so my team has been all in since the beginning on supporting and enabling Los Alamos and their progress. And I have to say, that's one of our big success stories. That team is really doing great work and making spectacular progress. We've also worked very hard to introduce new manufacturing approaches. We haven't manufactured at scale since the late 1980s. There have been several revolutions in manufacturing technology since then. And so we have had, for the last decade or so, a significant effort around advanced manufacturing technologies like additive manufacturing and advanced materials. And so we've been able to work, for example, with our partners at the Kansas City National Security Campus to introduce additive manufacturing, which does 2 things. It replaces a legacy process that required significant floor space. We have a lot of work right now, so capacity is a challenge. And it allows us to make parts with higher precision. So, we can do things with additive manufacturing that we couldn't do with traditional manufacturing techniques. We have partnerships with every element of the production enterprise. So with Y-12 and their work on uranium production, with Pantex, as we seek to modernize explosives production. We are all in on bringing the tools that stewardship has brought forward, computational tools, experimental tools, to help us understand how we can really transform the way we think about production. And so for 87-1, which will be the first fully newly manufactured warhead in 3 decades, we are the pathfinder for every element of production coming up across the NSC. And it's an extraordinary challenge, but one that my team is really up for.
This episode of Nuclecast is brought to you by the ANWA Deterrence Center, whose mission is to educate Americans about the nuclear enterprise and strategic deterrence. So in talking about a new warhead, one of the challenges, I often deal with my peers that are largely in the disarmament and arms control community. And one of their big concerns are always talking about, they talk about miscalculation and accidental detonation. And so, I have a tendency to remind them that we've never had an accidental detonation, that safety and security's always worked. We've blown up warheads, we've burned them up, we've done all kind of things to them, and the safety always succeeds. Can you perhaps, give us a little bit of sort of what's new in the world of safety? Because I try to tell them, I'm like, hey, that was technology from the 50s and 60s. Our technology is much better today. They're much safer than they've ever been. Can you go into a little more detail on that?
A little bit. So Livermore has a long history of leaning very heavily into new safety technologies. Of particular note is our effort to utilize insensitive high explosives. The goal there is to ensure that they work when you need them and they don't work when you don't, and make them as robust as possible in various accident scenarios. So that's a big part of why our weapons today are so safe, is that we've been able to advance the science of key components to do that, and advance the science and technology of other safety features. Our colleagues at Sandia National Labs, bear a lot of the responsibility for all the non-nuclear components, and have, been advancing technology for safety and security for many decades. So I feel good about that. Safety is paramount for us, not just once the warheads go into DoD custody, but they spend a lot of time in the custody of the National Nuclear Security Administration while they're being built and assembled. And so worker safety is also paramount. So thinking through that whole life cycle, not just how to guard against accident scenarios, but how to ensure that our workers who do this critically important national security mission are as protected as possible too. Very important.
So as we think about Livermore writ large, what are the programs that are going on across the lab right now?
So as we've already talked about, this transformation of the stockpile and the enterprise, and that is a big effort. So whole of lab motion. We continue to build on our ignition results and work to advance that science. And so there's a lot of great science going on at the National Ignition Facility, supporting fundamental understanding of nuclear weapons physics, understanding survivability and other questions associated to nuclear systems, but also doing basic science where we can create conditions that you can't find anywhere else on the Earth, but you do find in places like the center of the giant planets or the core of the Earth. So really extreme conditions, which again drives forward the science, brings new people, new ideas, new tools, new technologies to our national security missions. I'm very excited about our other security programs. We have a very significant biosecurity program that builds on the tools and the people that we have in hand. So in particular, we've been working to bring advanced high-performance computing at scale to the problem of computational drug design. And so the computers are big enough and the understanding of biological systems is getting sophisticated enough that you can really do modeling. During the pandemic, as an example, we were able to use computing to redesign antibodies to COVID as new variants emerged very rapidly. So in a couple of weeks, we could screen tens of thousands of candidate molecules and move forward with a new, more effective antibody in partnership with industry. We have a significant effort in energy and climate, really looking at the security considerations and the need to adapt to and mitigate the worst impacts of a changing climate. So for the Department of Defense, this is a big deal. If you think about the Pacific and where some of our bases are located, if you're on a remote island and you're dependent on critical infrastructure that the civilian sector provides, like the grid, understanding how to secure and make that energy system resilient, and how to make those, DoD facilities be more resilient as seas rise or extreme weather events increase. So using our climate modeling tools, which again, with today's computers, you can resolve at a level that allows you to understand local conditions. So the idea, sort of trying to bring climate toward weather. So that's been very exciting. I mean, it's really exciting, and it's an area where we're also creating partnerships in the state of California so that they can, the public gets the best benefit of the advanced technologies that we develop. I guess the last thing I want to mention is our work in integrated deterrence. This is a big deal for the Department of Defense, trying to understand how to operate in a much more complex battle domain where many, many different domains will contribute: cyber, space, conventional, hypersonics, nuclear. So understanding and building tools that help you think about conflict across a whole range of scenarios in a much more complicated multi-domain environment is something we've been working on with partners across the DoD enterprise. So I think that's really exciting, and it's a great way for us to use our expertise to help, make the capabilities that the U.S. has even more effective in this new environment.
Yeah, that's one of the topics I've spent a good bit of time thinking about. Like, how do you effectively understand when you've got 5 domains and nuclear and new technologies? If you do one thing in one domain, how is it understood by an adversary? How does he respond in a third domain? And it's quite a complex challenge that I sometimes wonder, is it too complex for, let's say, a political leader to truly understand the implications across all of them? So
we hope that, yeah. So basically what we hope is that some combination of modeling and simulation, systems analysis, tools that allow you to understand the interaction between different events, advanced wargaming tools, and through our Center for Global Security Research, we bring policymakers and technologists together. So the goal is to build tools that really speak to the policy community in a way that's effective. So I think it's a really hard challenge, but I think we have a good approach underway.
Let me ask you another question that sort of came to mind, and it's this question of knowledge transfer. So as you have a lot of the older engineers and designers and physicists getting close to retirement, and you've got and you sort of mentioned this when you were talking about manufacturing and going from the 80s to the present, and you're building new stuff for the first time, and you're having to create new manufacturing capabilities. And then it goes to this knowledge transfer question in terms of how do you have a effective program to capture all that and then transfer it into the to the brains of these younger folks who are coming in? Because to build a good designer, and it looks like the geostrategic environment is it's not on our side for a world full of peace. And so you need folks that are understand this design world and the experience we've had over the last 70 years. Do you have an effective knowledge transfer program? Maybe tell me a little bit about that.
Sure. This has actually been a huge focus for us for the last 5 years and 6 years in particular, because we have grown very significantly. So, once there was a consensus around nuclear weapons modernization, our lab grew by, 3,000 staff pretty rapidly. And the traditional model where one experienced designer works with one inexperienced designer over a long period of time to impart that knowledge doesn't scale. So the number of experienced designers was relatively small relative to the new influx of people. So we created new training programs to more efficiently transfer that knowledge, sort of one-to-many mentoring, much more structured and formal than we've done in the past, which I think has been helpful. We hired professionals who understand knowledge transfer and how to use technology to facilitate that, how to capture and archive important information, and really how to build more effective mechanisms for us to transfer the vast stores of knowledge we have from the history of the lab to our new staff, and then making really good use of our experienced folks and giving them a significant role as mentors. It's a fun time to be an early career member of our team because there's real work to do. And that means you're going to get a chance to do things sooner than you might otherwise, but under the guidance of someone who has been down this path before. So it's changed a lot about how we work, and I think we will benefit over the long run from the more disciplined approach we brought on this front.
Now, has this been, and I'll reason through analogy here, has this sort of been like, if you go back to the first Gulf War in 1991, and the U.S. Navy brought guys out of retirement who during World War II had worked on battleships and understood battleship gunnery, and they trained young sailors how to employ battleship gunnery. Have you brought in, old guys like Tom Ramos and others and said, hey, we need you to transfer knowledge and we need you to, is that something you guys have been doing, or do you have enough current lab employees to do all that transfer?
No, our retirees stay engaged with the laboratory. We keep them on as often as participating guests, sometimes as part-time employees. And Tom is a good example. He's been giving lectures on the history of the program very routinely, which is great. It helps people really understand the organization that they're joining and the great legacy that they're a part of, but also helps them understand how we ended up in the situation we are in today and where the technology has been and where it's going. And we have many more experienced folks who give graciously of their time to ensure, for example, we take groups of people to the Nevada National Security Site with some of the folks who were around during the nuclear test era so that they can hear firsthand about the history and what was learned and some of the great lessons of the test program. So I think that part is something our newer employees enjoy a great deal. They really like that.
Now it's that time in Nuclecast where I pull out Bob, the genie. And of course, Bob, if you can make 3 wishes, and Bob, he grants 3 wishes to all guests, but those 3 wishes must be related to the topic of discussion, and world peace is out. That wish was denied on guest number 1. So you get 3 wishes, and you're the lab director. So, you're kind of a good person to make some wishes about the lab. So if you had wish number 1, what would that be?
An appropriation for FY24. We really need it. We have important work to do and we need to get on with it.
Yeah, that's a good one. No more CRs. We need straight appropriations. That's a good one. Okay. So that's wish number 1, important one, big one, some stability. How about wish number 2?
So we have a partnership with one of the production sites where we're trying to replace a very inefficient old legacy process. And wish number 2 would be to send that legacy process to the history books and replace it with something great and new. Okay.
Yeah. So hopefully that partner is listening, and we've got this worked out.
They know who they are.
Okay, so wish you're actually kind of being easy on the wishes, right? So these are ones Bob definitely can take care of. Okay, so wish number 3.
10 megajoules in FY24.
10 megajoules. Folks, you heard it right here. 10 megajoules. Don't think Kim, don't think the lab, don't think NIF, think Bob, because this will be a result of Bob. So, okay, so 10 megajoules. We'll be watching now. Everybody's you sort of put the target on Livermore's back and on NIF's back. So everybody's like 10 megajoules, and then when we get to the the deterrence summit in January of 25, they're going to be like, hey, where was that 10 megajoules? So hopefully you'll get like 12 or 13 or something even better. Okay, so that's granted. Now, for the listeners, if you want to, let's suppose a listener doesn't really know Livermore, but they're an aspiring physicist or an aspiring chemist or an aspiring nuclear engineer, and they're thinking, what do I want to do? Where do I want to go? How do I want to spend a career? Because I just had a Ph.D. nuclear engineer she was my student, and she ended up going to a 3-letter agency, but I tried to direct her into one of the labs. And so if you've got those folks who are listening right now, what would you want them to know about Livermore to draw them in?
Yeah. So if you want to work on the most important, biggest challenges facing the nation and the world today, with the very best people you can imagine working with the most amazing advanced science and technology you can conceive of, and learn over the arc of your career many things. It's not one problem, one and done. I mean, I've had at least 3 different technical careers over my time at Livermore. So if you want that adventure where you'll always have to be on your toes, bring your A game, but it's never going to be dull, come to Livermore.
All right, you heard it right there, folks. All right, Kim Budil, thanks for joining us. We appreciate your time.
Thanks, Adam. It was fun.
And thanks to you, the listeners, for joining us on this episode of Nuclecast, and we will see you on the next episode. Well, let's see. We had a great interview with Kim Budil, and she's the current director of Lawrence Livermore, which is a, great lab doing great work. And we talked about a lot of things, really. I mean, it was the whole span of what's going on at the lab. So it was interesting. She mentioned a few things about ignition and, the work at NIF that were things I didn't know. So that was, for me, informative. And just to see sort of where they are on workforce and, all of that to better understand what they need. And, it's funny, stability. If you're a weapons lab, you need budgetary stability. That's one of the big things. It's for the DoD as well. Stable budgets are a big deal. So it was good to hear from her, good to hear what her big concerns were, good to hear where the successes are. So hopefully you'll enjoy the episode, or you did enjoy the episode as well.
This has been a production of the ANWA Deterrence Center, a 501c3 that seeks to educate key decision makers, stakeholders, and the public to ensure a broader understanding of the nation's strategic nuclear deterrent. Our executive producer is Kimberly Charrington, and this episode has been engineered and mixed by David Krumthal. Help us grow our followers by sharing it and follow the show on LinkedIn, Facebook, and Twitter at Nuclecast.